Chapter 6 File Systems. Introduction. File systems. A file system defines how files are named, stored, and retrieved from a storage device. Fundamental concepts on file. This logical storage unit is a file. The information stored in files are non-volatile, means they are not lost during power failures. A file is named collection of related information that is stored on physical storage. File system techniques. File system implementation defines how files and directories are stored and how disk space is managed. Special purpose file systems. File systems are commonly found on floppy disks, flash memory cards, digital cameras, and many other portable devices because of their relative simplicity. File systems. A file system is a set of data structures, interfaces, abstractions, and APIs that work together to manage any type of file on any type of storage device, in a consistent manner. Each operating system uses a particular file system to manage the files. What is a file system? Let's start with a simple definition. A file system defines how files are named, stored, and retrieved from a storage device. Every time you open a file on your computer or smart device, your operating system uses its file system internally to load it from the storage device. Or when you copy, edit, or delete a file, the file system handles it under the hood. Whenever you download a file or access a web page over the internet, a file system is involved too. 4. Characteristics of file system. The length and format of its records, the device type on which it is stored, the operations that you want be performed besides reading or writing record, the handling of errors detected by SAM, Software Asset Management. 1. Fundamental concepts on file. This logical storage unit is a file. The information stored in files are non-volatile, means they are not lost during power failures. A file is named collection of related information that is stored on physical storage. Data cannot be written to a computer unless it is written to a file to a user. The file is the smallest unit of storage on a computer system. The user performs file operations such as open, close, read, write, and modify. They can create or delete files from the system. In this article, you computers store information in storage media such as disk, tape drives, and optical disks. The operating system provides a logical view of the information stored in the disk. This logical storage unit is a file. The information stored in files are non-volatile, means they are not lost during power failures. A file is named collection of related information that is stored on physical storage. We'll learn the basics of file and file system. 1.1 Data and metadata. 1. Data. The term data is derived from Latin word datum, which refers to something given. Data is raw and unorganized facts that are useless without proper processing and organizing them to retrieve some information for future use. Data is a set of facts and statistics that can be operated, referred, or analyzed. It can simply be a piece of information, a list of grocery items, or observations, a story, or a description of a certain scenario. Data is any sort of information which is stored in computer memory. This information can later be used for a website, an application, or can be used in the future. Metadata describes relevant information about the data. 2. Metadata. Metadata is a data about data. Metadata shows basic information about data, which can make finding and working with specific instances of data easier. Metadata increases the accuracy of searching and operating of data from large amount of data. It helps in fetching piece of some data that is required from the bundle of data vastly. Metadata provides the information regarding organization of raw data. Metadata describes relevant information about the data. What is the difference between data and metadata? While data can simply be a piece of information, a list of measurements, or observations, a story, or a description of a certain entity, metadata specifies information about the original data which assists in identifying the nature and features of that data. Metadata is that data about an entity which is not necessarily a physical or descriptive aspect of it, but rather, certain intellectual information about it which provides more context for users of that data. 1.2 Operations, organization, and buffering in file. The buffer is an area in the main memory used to store or hold the data temporarily. In other words, Buffer temporarily stores data transmitted from one place to another, either between two devices or an application. The act of storing data temporarily in the buffer is called buffering. A buffer may be used when moving data between processes within a computer. Buffers can be implemented in a fixed memory location in hardware or by using a virtual data buffer in software, pointing at a location in the physical memory. In all cases, the data in a data buffer are stored on a physical storage medium. Most buffers are implemented in software, which typically uses the faster RAM to store temporary data due to the much faster access time than hard disk drives. Buffers are typically used when there is a difference between the rate of received data and the rate of processed data. For example, in a printer spooler or online video streaming, a buffer often adjusts timing by implementing a queue or FIFO algorithm in memory, simultaneously writing data into the queue at one rate and reading it at another rate. Metadata and data analysis. In the context of data analysis, metadata has a more specific meaning. Metadata is the information that is required for somebody to understand how to interpret and use the data. The most common types of metadata which are useful for data analysis are value labels and missing value codes, the domain, variable labels, variable types, relationship to other data, variable sets, and, in the case of surveys, change logs, weights, strata, and clusters. 1.3 Sequential vs consequential data as adjectives. The difference between consequent and sequential is that consequent is acting or operating in a consistent or logical manner, coherent, while sequential is succeeding or following in order. As a noun, consequent is the second term in various semantic or logical relationship where the first term is called. The sequential data refers to any data that contains elements that are ordered into sequences. Examples include time series, DNA sequences, see biomedical informatics, and sequences of user actions. Techniques for learning from sequential data include Markov models, conditional random fields, and time series techniques. High-quality example sentences with the consequential data in context from reliable sources. Ludwig is the linguistic search engine that helps you to write. 1.4 Content and structure of directories. The directory structure organizes these files by keeping entries of all the related files. The file entries have information like file name, type, location, the mode in which the file can be accessed by other users in the system. 14. 2. File system techniques. What is file system techniques? File system implementation defines how files and directories are stored, how disk space is managed, and how to make everything work efficiently and reliably. What are the 5 file processing techniques, file types and processing methods? 1. Relative record number processing. 2. Consecutive processing. 3. Sequential by-key processing. 4. Random by-key processing. 5. Sequential within limits processing. 2.1 Partitioning. A partition is a logical division of a hard disk that is treated as a separate unit by operating systems, OSes, and file systems. The OSes and file systems can manage information on each partition as if it were a distinct hard drive. This allows the drive to operate as several smaller sections to improve efficiency, although it reduces usable space on the hard disk because of additional overhead from multiple OSes. A disk partition manager allows system administrators to create, resize, delete and manipulate partitions, while a partition table logs the location and size of the partition. Disk partitioning. 2.2 Mounting and unmounting. Before you can access the files on a file system, you need to mount the file system. When you mount a file system, you attach that file system to a directory, mount point, and make it available to the system. The root/file system is always mounted. Any other file system can be connected or disconnected from the root/file system. These files are not permanently affected by the mounting process, and they become available again when the file system is unmounted. However, mount directories are typically empty, because you usually do not want to obscure existing files. 2.3 Virtual file system. An operating system can have multiple file systems in it. Virtual file systems are used to integrate multiple file systems into an orderly structure. The key idea is to abstract out that part of the file system that is common to all file systems and put that code in a separate layer that calls the underlying concrete file system to actually manage the data. Structure of virtual file systems in Unix system VFS also has a lower interface to the concrete file systems, which is labeled VFS interface. This interface consists of several dozen function calls that the VFS can make to each file system to get work done. VFS has two distinct interfaces, the upper one to the user processes and the lower one to the concrete file systems. VFS supports remote file systems using the NFS, Network File System, protocol. 2.4 Memory mapped files. A memory mapped file contains the contents of a file in virtual memory. This mapping between a file and memory space enables an application, including multiple processes, to modify the file by reading and writing directly to the memory. You can use managed code to access memory mapped files in the same way that native Windows functions access memory mapped files, as described in managing memory mapped files. There are two types of memory mapped files: persisted memory mapped files. Persisted files are memory mapped files that are associated with the source file on a disk. When the last process has finished working with the file, the data is saved to the source file on the disk. Non-persisted memory mapped files. Non-persisted files are memory mapped files that are not associated with the file on a disk. When the last process has finished working with the file, the data is lost and the file is reclaimed by garbage collection. 3 Special Purpose File Systems FAT, File Allocation Table. File systems are commonly found on floppy disks, flash memory cards, digital cameras, and many other portable devices because of their relative simplicity. Performance of FAT compares poorly to most other file systems as it uses overly simplistic data structures, making file operations time-consuming, and makes poor use of disk space in situations where many small files are present. ISO 9660 and Universal Disk Format are two common formats that target compact disks and DVDs. 3.1 Naming, searching, and backup strategies. Given the name of the file, the system searches the directory to find the files. It is for this reason that traditional types of backup strategies, file access methods, files store information. When it is used, this information must be accessed and read into computer memory. The information in the file can be accessed in several ways. Some systems provide only one access method for files. One sequential file access. The simplest access method is sequential access. Information in the file is processed in order, one record after the other. This mode of access is by far the most common. For example, editors and compilers usually access files in this fashion. Reads and writes make up the bulk of the operations on a file. To direct access, another method is direct access, or relative access. Here, a file is made up of fixed-length logical records that allow programs to read and write records rapidly in no particular order. The direct access method is based on a disk model of a file, since disks allow random access to any file block. For direct access, the file is viewed as a numbered sequence of blocks or records. File attributes. A file is named, for the convenience of its human users, and is referred to by its name. A name is usually a string of characters, such as example.c. Some systems differentiate between uppercase and lowercase characters in names, whereas other systems do not. When a file is named, it becomes independent of the process, the user, and even the system that created it. A file's attributes vary from one operating system to another but typically consist of these: name. The symbolic file name is the only information kept in human-readable form. Identifier. This unique tag, usually a number, identifies the file within the file system. It is the non-human readable name for the file. Type. This information is needed for systems that support different types of files. Location. This information is a pointer to a device and to the location of the file on that device. Size. The current size of the file, in bytes, words, or blocks, and possibly the maximum allowed size are included in this attribute. Protection. Access control. Information determines who can do reading, writing, executing, and so on. Time, date, and user identification. This information may be kept for creation. last modification, and last use. These data can be useful for protection, security, and usage monitoring file operations. A file is an abstract data type. To define a file properly, we need to consider the operations that can be performed on files. The operating system can provide system calls to create, write, read, reposition, delete, and truncate files. Creating a file. 2 steps are necessary to create a file. First, space in the file system must be found for the file. An entry for the new file must be made in the directory. Writing a file. To write a file, we make a system call specifying both the name of the file and the information to be written to the file. Given the name of the file, the system searches the directory to find the file's location. Reading a file. To read from a file, we use a system call that specifies the name of the file and where, in memory, the next block of the file should be put. Repositioning within a file, the directory is searched for the appropriate entry, and the current file position pointer is repositioned to a given value. Deleting a file. To delete a file, we search the directory for the named file. Having found the associated directory entry, we release all file space, so that it can be reused by other files, and erase the directory entry. Truncating a file. The user may want to erase the contents of a file but keep its attributes. Rather than forcing the user to delete the file and then recreate it, this function allows all attributes to remain unchanged except for file length but lets the file be reset to length 0 and its file space released. Backup. A system backup is the process of backing up the operating system, files, and system-specific useful/essential data. Backup is a process in which the state, files, and data of a computer system are duplicated to be used as a backup or data substitute when the primary system data is corrupted, deleted, or lost. There are mainly 3 types of backups are there: full backup, differential backup, and incremental backup. Let's take a look at each type of backup and its respective pros and cons. System backup primarily ensures that not only the user data in a system is saved, but also the system state or operational condition.